So Brian, can you tell us about this new piece of technology that's been developed here at UCD and it has benefits for a wide group of people?
Yes, this is an electrical muscle stimulation technology that we have developed in conjunction with an industrial partner, Biomedical Research. You might know them from their consumer brand name, Slendertone. It's an Irish company, and they've been working with a research team in UCD for the last number of years to develop an electrical muscle stimulation approach to cardiovascular exercise. So what we're doing is we're using an electrical muscle stimulation device, or what we call an EMS device, to apply a current to the tissues of the body, cause a contraction or a rapid rhythmical contraction of the muscles, and therefore kickstart a whole series of physiological processes that are very similar to going up on a treadmill or going out for a run, just regular cardiovascular exercise.
This is something that's of interest to ESA, the European Space Agency, because they're planning long duration flights to the moon and to Mars.
It is. When astronauts are a very, very fit group of people. To go into space, you have to be extremely fit. But unfortunately, when they go up into space and they're in what we call a microgravity environment, or sometimes it's called a zero-G environment, that environment has a lot of detrimental effects on their body. It affects their muscles, it affects their bones, and it affects their cardiovascular system. So when they come down from a period of time in space, they can have a reduction of 20 to 30% in their muscle strength. They can have quite a marked reduction in their cardiovascular fitness, and most worryingly of all, they can have a reduction in their bone mineral density. The European Space Agency and also NASA are very interested in finding what they call countermeasures, a series of interventions that astronauts can do whilst they're on something like the International Space Station that would prevent the detrimental effects of a zero-gravity environment.
So that, of course, is at the high end, but it's not just at the high end for very fit people and astronauts. This can benefit a much wider group in society.
Absolutely. A range of people. The reason we would have got into this work in the first place was not to benefit astronauts. Not that they shouldn't receive a benefit, but our motivation for getting involved in this work and the motivation of the industrial partner was to try and find new therapies for those people who find engaging in regular cardiovascular exercise quite difficult. So there's a large range of populations for whom daily involvement in exercise can be quite tough. People who have arthritis and therefore have a difficulty in loading their joints, people who have lung disease, people who have spinal cord injury and are not able to perform voluntary exercise using their limbs sometimes. So a whole range of people like that. Another group of people for whom this could be very beneficial for is the elderly. As a person gets older, the changes that they experience in their muscle system and in their cardiovascular system are quite similar to the changes that the astronauts experience in space. So this technology can also be used not just to help people with disease, but to also promote healthy aging. So Sean, here's Domenico doing a treatment session. He has an array of electrodes contained in a neoprene garment around each leg, and these are causing contractions in his muscles and therefore creating a demand for oxygen in the tissues, and that's getting his heart and lungs working just like he would in a regular exercise session.
So Dom, how does it feel at the moment?
It feels okay, like you're doing a little bit of work, and it would be comparable to a light jog or a walk outside. And here we are using pretty much half of the power of the total capacity of the stimulator. You can go through different stages according to your needs and according to the specific software that's been installed into the machine that has to meet the needs of the patients of the particular person which is using it.
And Brian, I believe you're looking for volunteers to test the technology.
Yes, we have a range of studies going on in UCD at the moment to test this technology on different groups. We're looking at people with COPD or chronic obstructive pulmonary disease, people who are suffering from diabetes, paraplegic patients from a spinal cord injury. So if anybody has seen this today and they think, oh, this could be suitable for me, or you know somebody who may be interested, it would be great if they could contact us. The details will be on the screen, and we're looking forward to hearing from people.